Alright, we're looking here at graphing rationals when we have a slant asymptote. And the reason why we know we're going to have a slant asymptote is because the degree of our numerator is bigger than the degree of our denominator. So that means automatically we're going to end up with a slant asymptote. But before we mess with that, just like normal, we're going to factor top and bottom if we can. So x minus 3 and x plus 2 as our numerator. Can't do anything with the denominator, leave it as x plus 3. So that means that's our only domain issue is at negative 3. And because it did not cancel, that denominator equaling 0 becomes a vertical asymptote and not a hole. No holes in this problem. X-intercept, just like we've been doing, set the numerator equal to 0. So when I set the numerator equal to 0, I'm going to get a couple of x-intercepts, so 3, 0, and negative 2, 0. The y-intercept, when I plug in 0 for everything, I get negative 6 over positive 3, so I will get negative 2 as my y-intercept as well. And all that leaves then is finding the horizontal or slant asymptote. We know in this case it's going to be a slant asymptote because of the degrees of numerator and denominator. When you have a bigger on top, you're going to have not a slant, or not a horizontal, but a slant asymptote. So x times what is going to give you x squared is how we're going to begin. That's going to be x. Multiply your way down. And we're left, when we subtract these values, negative x minus 3x is negative 4x. Bring down to negative 6, and I can do another layer of long division. So x times what gives you negative 4x? That will be a negative 4. So I multiply that down. I get the negative 4 that I need. Minus 12, subtract those two values, and I get a remainder of positive 6, so plus 6 over the x plus 3. So because I'm going to need to graph later on, I'm just going to get rid of this excess part here. And what I'm going to look at is the fact that my numbers in front of my remainder becomes my horizontal asymptote. So my horizontal asymptote is non-existent because I have an x. It's not a horizontal asymptote, it's a slant asymptote. So y equals x minus 4. Basically, if you have a slope, you have a slant. Just that simple. And as for where you cross, still the same thing. Here's your remainder. Set the remainder equal to 0. Well, 6 never equals 0, so I'm not going to cross this non-vertical asymptote. But now I can graph everything that I know, which I have a vertical asymptote at x equals negative 3. My slant asymptote is the line y equals x minus 4, meaning I would have started at 4, negative 4, and draw up 1 over 1. Same going in the opposite direction. The ordered pairs that I can plot are at 3, 0, at negative 2, 0, 0, negative 2. So I can now connect the dots to get one part of my domain. Hopefully you can connect your dots better than I can on my touchscreen. There we go. And now as for this part of the domain, to the left of that vertical asymptote, well, I can either draw above or below my horizontal, my slant asymptote. And it has to be below because if it was above, I would have crossed the x-axis again. So there's what your graph looks like in your slant asymptote here for example 8.